First, let's start with create the part, the pipe part. Ready, deformable solid extrusion. Continue, and let's create two circles. The first one with radius equal to 100, and the second one is, is with radius equal to 49. The first one is 100 in the diameter. That means we have 15 in the radius, and also the second one 49 in the radius. Click done. With the length of our pipe is equal to 2 millimeter. As you can see here, we have our pipe structure when we need to create the crack. Now we will create the second part that represents the crack and the circle in the front of the crack to create interaction, to create combine and merge between two parts to create pipe with crack. Let's go to the second part, add a name. For example, crack structure with 3D deformable shell extrusion. Click continue, and now we will create two, the main structure of our crack and the front of the crack. The first one is the crack line. For example, in our case, we will use 20 millimeter in the length of the crack, and also we will create two circles in the limits of our crack, and also create addition lines. These lines needs in the partitions for simplify the mesh in the geometry of our pipe. Click done, and add the length equal to, for example, 10 millimeter. As you can see here, we have crack and two circles in the front of the crack. This structure needed for creating the partition in the pipe. Let's go to the assembly and select two instances. Now we have this part and this part. Let's go to again to the part and select pipe. And create two datums plan to create interaction, to create partition in the pipe. The first one is NT plan with offset equals 0, and the second one the Y and Z plan. And let's go to create partition of the cell using datum plan. Select datum plan, create partition, and select two cells. Okay, select datum plan, create partition. Now we have two partitions in our pipe. Let's go again to assembly, and we need to move this part in the right position in our position of the crack. First, we need to rotate this part in the right position. Let's select the axis of rotation. okay, and the second rotation in the z-axis around the axis, okay. Now let's move this part to the position of the crack. For example, in this position, click OK. Now translate this part upper in the y direction with 5 millimeter. Now let's go to merge, cut geometry. Let's add a name, for example, pipe with crack. Press, continue, select the instance to be cut, the pipe, click done, and select the instance that will make the cut. We will make the cut by this instance, click OK. Now, as you can see here, we have the pipe with the partition of the crack and the front of the crack. Let's go to the part and pipe with crack. As you can see here, we have our pipe with crack partitions. Now, let's go to create property, and we will use elastic behavior for steel material. Elastic with young geometry is equal to 210,000 megapascal and potential ratio 0.3. Okay. Now let's go to create section, steel section. Continue, select the steel material. Okay, and select and assign the section to our part. Click done, and now we have assigned the material, the section with steel material to our part. Let's go to assembly, and in assembly we should to convert the instance to independent part. Let's go to the step and create static analysis step and change the increment, initial increment to 0.01 in our case. Now let's go to file output, edit, and in this case we need to get the J integral value. You can select GK, line spring, G integral stress and toxicity factor. Select this value to get in the output database. Click OK. And now let's go to the main step in our model is the creating the crack in the pipe. First, let's go to special crack assign seam, and we need to select the position of the crack. We need to select these faces where we need to create the crack. This value equal to 220 millimeter. This is the position of the crack, and click OK. This value, this selection means we have no material, no continuity of material in this section. We have, as you can see here, as showing, we have no material in this position. Click done. Now let's go to create the crack. We have two cracks. The first one in this position, the first front of the crack, the first contour, and now select normal to Q plane, select vector of direction of the crack, and click. You can select OK, and or you can select more options in the singularity by changing the value of mid-side node parameter 0.25 and collapse element side by single or duplicate node. Click OK. And we have the first crack. Let's go to the second crack. We have crack 1. Let's create another one. Crack 2. Select the front of the crack. Click on. Select the vector of direction of the crack. And also change the singularity. Okay. Now we have two cracks in our pipe. Let's go to the load and apply the load to our and boundary condition to our pipe. First is the encaster in the two limits of the pipe in the initial step. Click done on caster. Okay. Depending to your boundary condition, you can change this boundary condition and select second limits of the pipe. Click done and encaster again. And now let's apply pressure in the inner face of the pipe. In the step 1, apply select pressure, continue, and in this position select by angle to select the wall surface in one step. Click done and apply the pressure in the pipe. Our unit in the pressure is in the Newton per millimeter cube. You can change the value depending to your load. And now let's go to the next step is the mesh step. In this step, we will make necessary steps for make the mesh more adequate to our part. The first step is change the element type using mesh control, using hex dominated with the sweep technique, medial axis, click OK. Now let's go to mesh edges in the front of our crack by using the seed edges. Select edges in the front. Click on and select by number. Let's use 5 elements in these edges. And also you can change these size in these edges. Click on and also you can use by number, apply 5. Okay. And in these edges you can change the mesh using, let's use advanced front. Click OK. Let's go to mesh the wall part. Click yes. In this side, let's go to these cells and change the mesh using medial axis. Click OK. Delete previous mesh. Mesh again. Click yes. We have problem in these edges, this zone. Let's use triangular element. Okay, mesh. We have problem. Let's go to delete, see its element. Yes, and mesh again. Let's go to change the type. Let's use X dominate, sweep, medial axis. Okay, mesh again. Now we have a right mesh in front of the track. We have triangular elements. Depending to your problem, you can mesh. You can make your mesh more finer, but in our case, we will use for testing. Let's go in this part. In this step, let's go to the mesh to the step, and in the file output, in the history output, let's go to edit, select web model, select crack one, and select G-integral in 5 contours. You need to add and set the number of contours to get the value of G-integral. Click OK, and add another one. Select crack 2, G-integral, and also 5 contours. Click OK, and now let's go to the job and create job. We have completed job. Let's go to the result, and you can see the deformed shape. You can see the opening of the crack in our pipe. If you have a wrong shape in the crack, you can set the size of, you can use deformity scale factor and set to 1 or 10 to see the crack and the deformed shape. For example, if you use 1000, you can see this wrong deformed shape. Let's go to use 1. For this, the real value, you can see the crack in this part, but you can add more scale to see the crack clearly in your deformed shape. Let's go to the stresses analysis. Let's see the crack. Now you can take a look at the von Mises stresses in your front of the crack. Let's go to the history output. You can select the integral in fronts, in any fronts, in the crack 1, in the crack 2. For example, this one. And you can go to file output. Integral. We can see the value of G integral in the file output, ODB file output. Let's go again to, we can't get any real data. Let's go to deformed shape, and let's go to the job, go to monitor, data file. You can see the G integral in the contours, 1, 2, 3, 4, 5 contours in the crack one. As you can see here, the crack one, the value, and also in the crack 2, you can also see the value of the integral in each contour. First, let's go to create the patch part. Create part, patch, 3D deformable solid extrusion. Continue, and let's draw two circles. The first one and the second one. The inner circle is with radius equal to 50 millimeter, and the second one with 51. To get the radius, to get the thicknesses equal to 2 millimeter, to 1 millimeter. And now let's create two lines. The first one, second one, and use angle between two lines equal to 90 degrees, and go to create another line, and we can adjust the angle equal to 45. Now let's go to use trim tool to delete unnecessary lines. Now let's go to use the length of our patch equal to 100 millimeter. Click OK. Let's go to assembly and get the patch and use in our pipe. The first option, let's go to move the patch in the right position. Let's select the inner. Let's go to select the inner point in the patch, or you can use this tool, this point. Let's go to select direction of translation and use 100 millimeter. Let's use 50 millimeter. Now I think we have the right position of our patch around the crack. Click on OK. As you can see here, we have the patch in the top of the top side of the crack. Now let's go to property module and create property of the composite material, property of patch. Let's go to create composite, mechanical elasticity, elastic, use lamina type, and use property of the lamina in the all directions. Click OK. And now let's go to create composite layer. Go to composite layer, create composite layer, select and set the name composite patch, and also you can set the initial layers in our composite. For example, let's use 5 layers with continuum shell because we have solid part. If you have shell element, you can use conventional shell, but in our case we have continuum shell, we have solid parts. Click continue, and now let's go to select region, add material, element thicknesses, for example 0.2. Click OK. That means we have 1 millimeter in the thicknesses of our composite material, composite patch, and rotational angle. Click OK. Now let's go to edit our composite, and the main step is to select the orientation and reference orientation of our composite material. Let's go to select discrete definition of the orientation, select, and let's go to use surface and select the surface of our composite, the top surface. And now let's go to select edge and select the edge of reference orientation. Click done, click continue, and click OK. Let's again edit. As you can see here, we have the orientation. The reference orientation is in the direction with the edge of our composite patch. Click OK. Now let's go to query, play stake plot, and select the material, and you can see this reference direction, the direction 1, 2, and 3, and all layers in our composite with thicknesses and orientation. Now let's go to interaction and create tie interaction between two parts, the pipe and the patch. Let's go to create constraint, tie, continue, select surface with select by angle, and select the top surface of our pipe. Click done. Also select surface. Let's select the inner surface with contact with the pipe. select the slave surface, click done, and now you can see the main and the secondary surface, click OK. Now we have tie interaction between two parts, the patch and the composite. Let's go to the load and mesh. In the mesh step, let's go to the mesh part and mesh the patch. And as you can see here, we have the mesh of all parts in our model. Now let's go to the job and create job. Continue, click OK, and submit. We have aborted situation. Let's go to resolve these errors. The first one is the missing property definition. This error happened when we have a wrong mesh type. Let's go to the patch part and go to element type and select continuum shell, because we select continuum element in the type of composite material. Click OK. This is the first errors and warning. The second one is the orientation of the material. Let's go to select assign stake direction, select the top face, click yes. Now we have assigned orientation of our parts. Let's go to run again, submit. Now we have completed job. Let's go to the result, and you can see the deformed shape. Let's go to see the stresses in the crack. Let's use the scale factor to see the deformed shape clearly. You can see the crack, and also you can get the stresses. Let's go to open a new viewport and open the previous ODB file to make the comparison between two models. You can compare between force stresses in the front of the crack and see the effectiveness of your patch around the crack to minimize the failure and stresses in the front and tip of the crack. Also, you can go to the job and see the geocontour integral value in the repaired pipe using patch. We have the first crack contour, G integral, estimate, and also the crack 2, and compare with the crack without the patch. Until now, I hope you enjoy with this video. Don't forget to subscribe in my YouTube channel and like this video. See you.